Hi everyone. Thanks for showing up so early here in the morning. How many of you saw this black card in your bag when you checked in for the conference and are here because you're expecting to see some guy from Splunk talk about next-gen security teaming together to prevent attacks and protect your data? One. That's good, because as you can see, we've sort of completely changed the presentation on us to make it infinitely better. So what happened was that I was going to stand up here and talk about Splunk for quite a bit of time. And we decided that it would be much better for you to experience exactly what it is that a customer would have in terms of success integrating Palo Alto Networks data and Splunk. So Kevin here from Lennar Corporation is actually going to do a presentation, and I'm going to fill in some of the blanks when it comes to the Splunk technology. So my name is James Brodsky. I've been at Splunk for about 4 years. I like long Splunks on the beach, and I am a huge Lifehouse fan. Right. I didn't know that until last night, but anyway. The best technology job I've ever had, and one of the best things about Splunk is that it's constantly surprising me and our customers with what it can do. And one of the best parts about it is being able to see the success that customers like Kevin have. So I'm really proud to be able to present up here with him today. So hit the next slide there, and we'll get started.
So I am Kevin Gonzalez. I'm a security operations manager at Lennar Corporation. Just to fill you in on what Lennar does, Lennar is a bit of everything in terms of in what industry it's in. So we are a home builder. We work in financial services with a mortgage and a titling division. We have international presence. We have energy. We're in the energy industry with SunStreet. We have asset management, our own desk on Wall Street with one of our subsidiaries as well. It's a public company, Fortune 200, revenue of over $11 billion a year. We have over 11,000 endpoints, over 15,000 endpoints, over 11,000 employees, and home to over 40 Palo Alto Networks firewalls.
There you go, cool. Yeah. Right. So as I said before, I'm James Brodsky, based out of Denver, Colorado. I manage a team of sales engineers, and that's my day job, and my afternoon and evening job is to be a security SME for Splunk.
That works. All right, so here's our agenda for today, right? We're going to go over a little bit about Splunk Enterprise Security, Palo Alto Networks, and threat intelligence, and pretty much how Lennar Corporation has integrated those three aspects. Really, what we're looking at is the main integration is Splunk Enterprise Security and Palo Alto Networks, and then how we utilize the threat intelligence data models within Splunk ES to populate Palo Alto Networks firewalls threat intelligence portions. The next aspect we're going to be going over is user ID. So how can you populate user ID utilizing Splunk? So I know a lot of customers have issues with user ID and actually getting that user affinity out onto their actual networks. So we're going to go over what our dilemmas were, some use cases that we actually applied, and then how we actually use Splunk to solve those use cases. The next aspect is the Splunk Universal Forwarder. So the forwarder is deployed at every endpoint, and we're going to go a little bit more into that. But most people don't realize just how powerful the forwarder is and what the kind of data that you can collect from that is. And we're going to go into just what you can use the forwarder for as it relates to Palo Alto Networks. And if we have time, we'll have one more thing.
Awesome. So how many of you guys, show of hands, have heard of Splunk? How many of you are, well, that's everybody. How many of you are Splunk customers? About half of you. Okay. Cool. So for those of you that everybody's heard of Splunk, but for those of you that are not customers, just a quick review of what Splunk is, and we'll also talk about enterprise security just for a minute or two. Splunk is a basically infinitely scalable platform to gather machine data, store it, and analyze it all in one place. And so that has really interesting security implications, because if we have a record of humans interacting with machines and machines interacting with machines all in Splunk, and we can search all of that at scale, that's a really wonderful thing for your security operations centers, incident response, forensics, et cetera. Any data with a timestamp can go into Splunk. Splunk can be hosted on-prem. Splunk can be hosted in the cloud. Splunk can also work in a hybrid manner, so you can have data in both places and search it all from one place. On top of Splunk, and we call it Splunk Enterprise or Splunk Cloud, we have a product called Enterprise Security. It's one of our premium products. This is our SIM-like functionality. It's up there in the top of Gartner Magic Quadrant. And it really adapts Splunk and gives significant capabilities for incident investigations and forensics, security compliance reporting, and monitoring of known threats. And since that sits on top of the Splunk core technology, what we're going to hear is some of the use cases that Kevin is going to get into leverage the enterprise security and the data models underneath enterprise security, and of course, core Splunk as well.
So why did Lennar choose Splunk, and why did we choose Palo Alto Networks? So just to go a little bit into that, we were in the middle of standing up our enterprise security operations center, and we pretty much needed something that will fulfill our incident response needs. At the same time, we had very outdated firewalls. We had very basic rule-based firewalls with some basic web proxies, nothing crazy. It was very outdated, and we needed to upgrade all that. So for the firewalls, the solution was unified threat management platform, right? So Palo Alto Networks kind of fit that for us. And in terms of incident response and a security operations center role, Splunk Enterprise Security definitely fulfilled that for us. So just to go a little bit more into that, right? What Splunk Enterprise Security gave us is a single pane of glass. We're able to go and not just in Palo Alto Networks rules or Palo Alto Networks alerts, every single platform, every single agent, everything that we have within our environment, we can go and look at all that within one pane of glass and be able to correlate that information rather than just looking at the firewall. This is the logs, this is the alert, this is what generated that, but we don't know what happened on the endpoint. We don't know what happened within the access points. We don't know what happened anywhere else because we're only looking at one location. What Splunk Enterprise Security allows us to do is create those notable events there and actually correlate that information with everything else. Another key aspect, right, is so with the new Security Operations Center, you're kind of stuck on the amount of time you have to investigate the amount of incidents or false positives or true positives that you may have to go through. So adaptive response with enterprise security actually gave us a really competitive advantage over that. One of the key things to note is when you're going and creating a notable event, you're creating correlation search, you can add adaptive response measures such as auto-submit this IP address or this URL to Wildfire. So you get an automatic analysis right into Splunk. Another thing you can do is do tag your let's say Botnet Alert comes in, and that's what you've customized within Splunk ES, and you want to tag that IP address into a dynamic block list. You can do that right off the gate, or you can just have it automatically do it if you have trusted threat sources or anything like that, and we're going to go a little bit more into that. So with the Security Operations Center, we also had threat intelligence needs. We wanted a centralized platform. We wanted to be able to go and manage that platform in terms of filtering it, in terms of deduping it, being able to pick and choose exactly what we wanted to utilize within our firewalls. And really this integration, which we're going to go into, and I'm going to show a couple searches and what we use to actually do that, and it's pretty neat.
Yeah, hit the button there.
Sorry, I didn't see it.
No problem.
All right, so going into those botnet alerts, this is one of the key items that we actually plugged into Splunk Enterprise Security. This is not out of the box, but it just goes to show that you can do anything you want, right? If it's there, you can create it. So going into the auto wildfire submissions and per notable event tagging for Palo Alto Networks, what that screenshot on the right there shows is a Botnet Alert that we created using Splunk query language to automate or create what the firewalls show you on their devices. So instead of getting an email alert or having to go into the firewall to go and investigate an action, you can just create that within Enterprise Security and correlate that with other logs, other information, so you get a better picture of what's going on in your environment. Like I said, you can go and do automated actions, adaptive response, or you can go and actually do manual submissions. So for example, maybe you don't want everything to be tagged into a dynamic block list because you're probably going to break some stuff, right? You can have the action, which in the screenshot all the way to the right, there's a little drop down. You can click on it and say, well, I want to tag this IP address, or I want my Security Operations Center analyst to be able to tag whatever's in this notable event or whatever's in this botnet and say, tag this with this tag because I know this tag is in this dynamic block list, and now you know that's going to be blocked in the future. So another neat thing you can do utilizing Splunk Enterprise Security is leveraging the threat intelligence data models. So within the Palo Alto Networks threat intelligence portion, you don't have a lot of, unless you have mind meld, of course, you don't have a lot of customizability in terms of picking and choosing and filtering. You kind of just get one large data dump into the firewall and you're stuck there, right? The firewall is just going to use everything that's in there, and you don't have any management over that. So utilizing Splunk Enterprise Security's threat intelligence management portion, or the data models, you're able to go and choose all your threat intelligence sources, go and dedupe that, filter that, pick and choose time frames or how you want to utilize that, and have auto-submit or auto-tag that into your firewalls. You can also just publish it down to an IIS server, and then your firewall only has to read 3 files rather than hundreds of files, tens of files, or whatever it may be. So what we did is we actually just published an IP file, a domain file, and a URL file, so that way our firewalls only have to read 3 things that we manage. So going into a little bit of that botnet alert, this is kind of what's the back-end portion of that alert, right? As you can see here, you kind of create a correlation search. You just name it what you want, write a description. You put the search query that's actually running that, which that is the search query that's in that box, just nicely formatted and colored with Crayola for you. And you can choose the time range that you want this search to run on. In our case, 15 minutes or every 15 minutes would give us what we considered a good amount of time for a host to contact external IP addresses, external threats, to be able to determine a botnet. And then we have our adaptive response action. So at the bottom there, you can see that we wanted this to create a notable event. We also used it to actually create a risk analysis by saying if this user is in here, or if the user field is in here, maybe put a higher risk to this. And within Splunk Enterprise Security, for those of you who don't know, you can actually put higher risks to maybe your executives and whatnot. So on the scaling of things, you know which ones to react to first. You can also do, like I said, auto-submit URL to Wildfire, so you get your automated analysis. And you can do the tagging to dynamic address groups for dynamic block lists and et cetera. So I'm going to go into that search a little bit more. So what's that search do, right? Maybe I should grab this giant green lantern thing.
Yes.
To start off, most of you may be familiar with the index PAN. In our organization, we're very diverse. We have a lot of subsidiaries, so we've actually parsed each subsidiary with their firewalls into their own index. So for Lennar, we have len_pan, we have rcm_pan, we have uamc_pan. So we had to parse them out. So this is how we go and we look at every single firewall within our organization. So whenever you see asterisk within my search, it means I'm searching the entire enterprise and all of its subsidiaries, not necessarily I created some sort of weird index or anything like that. So we're going to go over the PAN threat source type. We're looking for anything that's tagged as potentially malware and internal IP space that's going outbound. From there, just because we don't want to lose any information by using stats, we're just going to fill null. So any source user that's not tagged for whatever reason, just fill it out with a blank value just so we don't lose that data. Then we're going to parse it into a stats command so we can actually get a counter of how many times a particular device, a user, source IP, contacted an external site that's potentially malicious. From there, we just dump that into a table just to kind of sort it neatly. And then we ran event stats. So event stats is essentially stats within a stats, right? It's like statsception in a sense. So we can go and utilize the count that came from here, sum those counts by client IP. So now we know, okay, how many so we had, the initial stats gave us how many per individual site, now just how many for all the sites. So we actually know how many malicious sites a certain IP or a certain user visited within X amount of time. And then from there, if it was greater than 4, we determine that as a potential botnet, or at least something for our security operations center analysts to actually look at. After that, we have a lookup, which we're going to go into what lookups are. And really, this is utilizing the URL Toolbox applet within Splunk and within Splunk base. And really, the purpose of this piece right here is just so when that notable event gets created, our security operations center analysts have a little bit more fields to work with just in case a false positive keeps being generated. We can utilize those fields that are added via the URL toolbox and maybe create a very intricate or very specific suppression rather than going and suppressing something or suppressing too much, because that's always bad. All right, so I went over how you can go and just tag or automatically tag your trusted threat sources. I briefly described that. a couple slides ago, and I just wanted to really quick go over the search behind that. So this is kind of running off the same thing that we just went over, but instead of creating a notable event at the end, we just have this running in the background. So we have Splunk collecting all the threat intelligence. In this case, we're going over IP intelligence, and it's aggregating that, deduping that. Now we want to go and choose our most trusted threat sources. Now, of course, you can always add a couple more pieces into this to filter the data a little bit more and dedupe it. I just wanted to give the basic search command just so you can see how it works and how you can utilize it. And you utilize the Pantag commandlet, which is within PanW's app within Splunk base. And really what you're doing here is you're pulling all the IPs within your threat intelligence data model. You're choosing your most trusted threat sources and then just tagging those devices with whatever tag. No, bueno means not good in Spanish, so that's what we called it. We're in Miami, so we have to. And we're going to add all those IP addresses into this tag so they're automatically blocked within the firewall. So we're having Splunk ES manage our what we wanted blocked all the time, every day, right? It's just easier that way with a small team, especially when we really trust these threat sources because we've reviewed the data, we know it's always good or 99% good, and we can trust it.
Right, so there was a couple of concepts there on Kevin's last couple slides with the searches that I wanted to go into a little bit more detail just so you can understand some of the concepts a little better. This is a modified version of the first slide that I have up in terms of what is Splunk, but if you see here at the bottom, there's these external lookups. One of the magical things about Splunk is that all of the data that you're going to analyze and search on in Splunk doesn't necessarily need to be indexed in Splunk. Splunk has very powerful ways of taking existing data in Splunk and correlating that against other external data sources. Those can take many different forms, but one of the things that we were seeing before is that Kevin's doing a lookup against something from our URL Toolbox app on Splunk base, which we'll talk about as well, to get some additional fields into the data that don't exist there in the actual data. They exist at search time, and they're parsed out by that special command or special lookup. Lookups take many, many different kinds of forms. The most basic kind of lookup is a CSV lookup. Also underlying more recent versions of Splunk these days, we have something called a KBStore, which is actually MongoDB underneath. Gives us a little bit more power and flexibility for lookups. You can also do dynamic and scripted lookups, so actually run some commands, maybe a Python script underneath to enrich your data. Lookups can be also fed from a database. Lookups are really highly performant. They can get really, really, really big, and we do some clever things with indexing lookup data underneath to make sure that they stay performant. They can also use to store state between searches as well. And they're extensively used in enterprise security and also the Palo Alto Networks app that's out there on Splunk base, which we'll talk about at the end a little bit. Two really powerful apps that are available on Splunk base. These are free community apps, but they're developed by people that work at Splunk. URL Parser and URL Toolbox. As analysts, there's an awful lot of work that we want to do with things like URLs and domain names, et cetera, to be able to parse out the different components of them, the top-level domains, et cetera. We also might want to do analysis against those domain names. So maybe you're trying to search for dynamically generated algorithms, or maybe you're trying to do some fuzzy matching and you want to do a Levenstein algorithm against that, or Shannon entropy, those types of things. All of those are built into those two apps, and we see that people that are doing analysis of intricate strings in their data, especially from a security perspective, really love these two apps. Finally, one of the searches that Kevin showed also talked about Splunk data models. This is an acceleration technology. Well, it can be an acceleration technology, but it's essentially a data exploration technology and an acceleration technology that we introduced back in version 6.0 of Splunk. This is incredibly powerful. This allows you to pre-publish a schema on top of the raw data. And then once you've pre-published that schema, you can accelerate that. And so the ability to search many, 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 many gigabytes, terabytes, et cetera, of data very quickly within Splunk usually uses the concept these days of an accelerated data model underneath. So if we want to get threat intelligence out of Splunk really, really quickly, we might use the threat intelligence data model that comes with enterprise security, which is exactly what Kevin did. And then lastly, one of the searches used the Pantag command. And so if you download the Splunk app for Palo Alto Networks, one of the things that it has in it is the Pantag command. There's a couple of other custom commands that we're going to use, but that's where you get this. And essentially, that allows you to take IP addresses and move them inside and out of dynamic address groups right from a Splunk search, like was done there in the last search that Kevin showed. You're up.
All right, so let's talk a little bit about user ID. Market, right? The market's great. Shut up and take my money. It's improved visibility. We got policy control. We got logging, reporting, and forensics. Every time you get an HR request or a legal request, you can say, hey, I know exactly who that user was 3 months ago. This was his IP address. I know everything about it, right? Yeah, we had some problems. So being a very diverse shop with different subsidiaries, non-Microsoft endpoints, a lot of SaaS applications, no centralized point for a user ID agent, it was very difficult for us to try and fulfill or fill this user ID agent with actual user ID to IP mappings. Especially when one of the most recommended places to actually put a user ID agent is an Exchange server. Well, for Office 365 customers, you're kind of dead in the water for that, right? And then another thing that we kind of lacked was historical data. We didn't have some sort of log that actually gave this for us, or that we were already doing, that we can just put a user ID agent there and just say, hey, just ingest all this, and we are good. Well, at least we'll have everything since the beginning of time. So I kind of sought out to see how we can actually populate this agent and how we can get all user ID to IP mappings since the beginning of time, or at least since implementation time. Right? So this is a high-level solution overview of kind of what we're utilizing today. We have other solutions, but these are the main use cases just due to time constraints. These are the ones that we're going to go over. So as you can see here, basically what this diagram describes is the relationship between our environment with Splunk in the middle. So there's a couple key things to know here, right? One, we are collecting all logs from everywhere in our organization. So in this case, we're talking about Meraki access points for wireless devices. We have our endpoints, so we have MacBook Pros, we have Macs, we have Windows devices. We have a little bit of everything. We have Linux servers, we have everything. And then we have our radius servers. So we also have our firewall populating Splunk, but the two main things to know here is that we're actually using Palo Alto's own data to populate itself back. We're using these three sets of data to populate the firewall's user ID agent as well. And we're utilizing the Meraki data to enhance the radius server data to actually give us one complete picture. And I'm going to go over that just now. So you're updating user ID with radius logs. So given X amount of incomplete sources, you can depict a full picture, right? So if one set of data has half the information and another set of data has the other half, and there's at least one identifier where you can link those two sets of data, then you can go and actually create one full picture and utilize that information to populate user ID in this case. So given said that, within our wireless access point logs, we had device MAC address and we had device IP address. Great, we had the IP address, but we were missing the user field. Within our radius logs, we had the user field and we had the device MAC address, but we didn't have the device IP. What the radius servers were giving us were the IP addresses of the actual access points rather than what the user was getting. So what we did was we grabbed the AP logs, we created an automatic lookup, or we used the output lookup command, or output CSV, sorry. And basically that's running every X amount of time, outputting a CSV onto the Splunk servers, and then we're utilizing that CSV to do an automatic lookup back into the radius server logs. So now every time we search the radius server logs, we know the user that's tied to each individual log based off that MAC address. So the search behind that is that first one, right? So this search is the one that's running every X amount of time and actually outputting the lookup of the Meraki source.csv into Splunk. And then from there, we're utilizing that CSV, creating an automatic lookup, like I said, within the settings, and applying it to our radius server logs. So now when we run this search here, we'll always have the user ID. So let's go a little bit more into that, right? Because there's a couple commands that maybe some people are not familiar with. So in this one, Rex is just regex statements for field extractions. So in this case, we're extracting the source IP from the logs because our Meraki data didn't have some sort of extraction. and then the output lookup, as I mentioned, to go and actually output that CSV as a lookup table. In here, we have mv expand, which that one's actually a very powerful command. So sometimes you get logs where there are multiple values to one particular field. This happens in Windows event logs all the time. Within the security ID, you'll have an issuer security ID and you'll have a target, you'll have an issuer security ID and a target security ID. And when you go and you look at the security ID field, it'll have 2 values for 1 log. But if you output that into a table, it removes one of those values. So you just cut your information in half. So what multi-value expand or mv expand does is actually go and it undupes that log or unduplicates. It kind of it goes and it creates that log and it creates it again, but with the second value in that field. So now when you parse it into a table, you're getting 100% of your data. So from here, we go and we grab the security ID and then we multi-value expand it. So now we have 2 logs to get every single piece, or multiple logs, depending on how many security IDs, within a table. We do the same for source IP, just in case, and then we dedupe that just in case there's multiple values that just equate to the same thing. From there, we utilize the pan user update, which we'll go into, to actually update the user ID field and the IP address into the Palo Alto Networks firewall so that we can actually get that user affinity.
Right, so pan user update is the second of 3 commands that come in the Palo Alto Networks app that's on Splunk base. This is pretty simple. Just like Kevin mentioned, essentially what this is allowing us to do is take a couple different fields, specifically the IP address and user field, which are by default, and feed that either directly into a Palo Alto Networks firewall device or into Panorama and dynamically update right there from the Splunk search interface. By the way, the third command, which actually isn't listed in the presentation, is an update pack. There's a few lookup tables, again, that come with the app for app data and threat data. And that third command that we're not going to talk about pulls data out of firewalls or Panorama and updates the lookup tables right within Splunk.
So now let's move into the next piece, right? So now we're going to talk about updating user ID with session initiation protocols and other best guess scenarios. So this is where I was talking about utilizing Palo Alto Networks' own data to populate it back with its own user ID agent, right? So one thing to know about your environment, you have to know all the applications and all the logs that those applications output. You have to know the information within those logs in order to best utilize it. In our case, we use Skype a lot, formerly known as Link. And what Skype does is that it passes the SIP username within URL traffic. And what we did was we noticed that and we started going and extracting those logs or that usernames, tying it to the IP address that it was coming from, parsing that into a table, and then updating the firewall with that. So that's this course right here, this search right here. All right, so we're searching our firewalls. We're looking for any URL that has that SIP URI command, extracting the username within that field, doing a multi-value expand, because it's always good to do that. Deduping that data, searching where the user's unknown is not equal to unknown, and then we're going to go and update Panorama with the user ID to IP mappings. The second piece here is more of our best guess scenario. So now that we learned our SIP data and that we can extract usernames from our URL logs, what else were we actually sending across our network that contained that same kind of information? Now, it wasn't going to be as exact as SIP because, well, it could be anything, right? It could be apps, it could be anything. People can pass any kind of username for whatever reason. Maybe they're using somebody else's username or something that doesn't get tagged correctly. So what we did was that we created the same kind of search. We were looking for all of our email addresses, so any domain that we owned that was being passed within a URL parameter. And we went and we extracted that, and we put an asterisk in the middle of the log, or in the middle of the user. The reason we didn't put it at the beginning or the end is because the Palo Alto Networks firewalls won't actually read it. You can't update it if there's an asterisk at the beginning or at the end. So we're using the asterisk as kind of like a wild card saying, hey, this is a best guess. The benefit of this is that we're only populating logs or IP addresses that don't already have a user. So if there's no user, this is what we think it is, right? And what that gave us is, it gave us kind of a point of reference on where to begin when we got a request from HR, when we got a request from legal, or when we just needed to investigate an incident, right? It's saying, hey, we believe this is the user tied to this. We need to validate that, but at least we know where to start, right? Another huge benefit of this best guess in the SIP URI traffic is you get a lot of user ID to IP mappings that you won't expect to get. You get unmanaged devices, you'll get mobile devices, you'll get people that are just utilizing it on their personal, like iPads, personal Android tablets. You'll get pretty much anything that people are utilizing their company email addresses or their company usernames and passing that traffic via URLs. So it gave us a huge advantage of information that we would have never collected if we didn't utilize this. Okay, so this one is my favorite. So we did the first two, and we got a lot of the data there. We got about 50%, 60% of our actual user ID agent populated. Now, the question is that how do we get the rest of it? We're kind of going around the sources. We're gathering from servers, from agents, from URL logs, but we're kind of going around where the true source was. We can all agree that endpoints are the true source of user IP mappings, right? They contain the user that's logged in, all LAN IPs, all WAN IPs, or any other IP that they have. They have extra NIC cards with IP addresses tied to it. You can gather that too. So what we did is that we utilized the Splunk Universal Forwarder. Splunk Universal Forwarder is your friend. It does whatever you need it to. And when I say that, I mean that really wholeheartedly. You can do anything you want with the forwarder. So in our case, we created a PowerShell script, which I posted here since most people use Microsoft. And we created a Python script that does the same thing for Macs. And what this does is this script runs at the endpoint. The forwarder executes it every X amount of time. And it's collecting the username that's currently logged in using WMIC, and then runs the WMI object command, pulls the network adapter configuration, and writes all the IP addresses that are within that network adapter configuration to standard out. So the forwarder's just reading that, sending it up to the indexers, and it's there for you to read with your search heads. From there, we parsed it into, we have any custom script that we create, we put it in a script bucket, just because it's easier that way and our other indexes don't get filled up or cluttered with data. And we ran this search, so our source type, script, user affinity, and anything that has an IP address, just in case, just because we wanted to make sure that that filters out. What we did was we extracted the username, extracted all the IP addresses, so doing a regex statement and putting a max match value of extract up to 5 IP addresses from this device. And then we're going to go and do a multi-value expand, because when we go and we extract 2, 3, 4, 5 IP addresses, that's all those values are being dumped into one field, into one log. So now you have one log with 5 values in one field. Can't really do anything because now we're stuck that we're going to lose a good majority of the data that we're collecting. So use multi-value expand, parse that out into X amount of logs depending on how many IP addresses you grabbed, put that into a table, and then update the firewall with all that information. This got us to 99% of user ID capacity. So we have very few logs that don't have a user ID to IP map to it. The ones that we don't have are basically unmanaged mobile devices that may be connecting to our network or something like that, or just something that we just, for whatever reason, we missed. It's always the unknowns, right? And then, we'll stop there. I could keep going.
All right, so just a little bit about the Splunk Universal Forwarder. This technology is a very stripped down copy of Splunk, extremely lightweight, runs on pretty much any flavor of Windows you can think of, including embedded ones, POS ones, et cetera, as well as Windows, as well as Linux, and a couple of other operating systems. It's centrally configured, and as Kevin said, it has significant amounts of flexibility. Its main purpose in life is to collect things like Windows event logs or flat files that you might have out there on an endpoint. But there's so many more things that you can do with it. We've seen an awful lot of popularity with it to collect Microsoft Sysmon data. We have another free app that goes on to those forwarders called Stream that will turn the NIC card into promiscuous mode and capture network data directly off of anything that endpoint is seeing. It can collect perfmon counters, registry values, and how they change over time. And as we saw with Kevin's example, it can also run scripts and take the output of those scripts and put that in Splunk. And so Very, very interesting technology that sort of the world is your oyster when you have these things deployed across your network. And so we'll see another very, very creative thing that Kevin did with the forwarder here on the next slide.
So before we go into the creative thing, right, let's talk about a little bit more on how you can utilize the forwarder on your endpoints to actually make a better integration with your Palo Alto Networks firewalls, right? So there's a couple things that we're currently doing today. We're doing Global Protect install validations on the forwarder. So the forwarder is constantly checking, hey, is Global Protect installed? Grabs the version that the user has on that device. We check all of their settings so we exactly know exactly which gateway, portal, user ID, their agent, their pass, everything that's saved on that agent. And storing it all in Splunk, so that way if there's ever a VPN issue, if there's ever anything, we know all the information on that user, all the settings they have, everything they're utilizing before we even contact them. And that saves us a lot of time because more than likely we can correlate it with other information. Maybe we see, oh, hey, well, this version is having X amount of problems, or we keep noticing this same version is having this problem, and we can correlate that information, actually get true value out of it. It also saves us time because we know all this information before we even contact somebody. Another cool thing that you can do is you can actually assess your egress points. So what we're utilizing the forwarder to do, now this isn't directly to Palo Alto Networks, but it's definitely a good point on where you need to put a firewall or where you need to make a network configuration to adjust your network traffic to go through a firewall, right? So what this script is, it's a PowerShell script. It goes and we have a Python one as well. And unfortunately, due to time constraints, I'm not going to go into the code of it. But what this is doing is that it's checking, every single forwarder is checking its external IP and validating whether there's a firewall in between itself and the public internet. If it sees that there is no firewall in between, it goes in, it sends a log up to Splunk saying, hey, this is my external IP. I have no firewall. We need to fix this. So this helps a lot when networking starts making changes that we don't like because networking and security don't like each other. And it also helps us know the unknown. So let's go back a little bit. Security in Lennar was established, at least an official security program was established not more than 3 years ago. So 15 years of bad networking can lead to a lot of holes, right? So the first thing we did when we had the forwarder was we implemented that so we could say, okay, well, we don't know all of our unknowns, so let's find them. Let's use the forwarder to go and say, where are all the points within our network that we're not protecting? We implemented this and we just pushed a firewall to all those locations, or we routed them back to a place that had a firewall. So this plugged every hole in our environment and allowed us to do that very rapidly. And the next thing you can do is bug workarounds. So as James said, you can go and utilize the forwarder to collect things. You can collect anything you want. You can create a custom script. But what about fixing things? How can you utilize the forwarder to fix something? So let's go into a very specific example as it relates to Palo Alto Networks. So we noticed we have Global Protect installed in all of our endpoints. We have Ubiquitous VPN turned on, so VPN always on. And we noticed that on version 3.0.x in our environment, under these particular circumstances, so Ubiquitous VPN, specifically on Windows, and when there was an ungraceful network disconnect. So for whatever reason, computer maybe ran out of battery, and the computer just shut off, and the Global Protect wasn't able to reset the DNS settings, or whatever the case may be. Anything that qualifies it, maybe they disabled the NIC card or something like that, and then the DNS settings gets frozen just because Global Protect isn't able to reset them on that version under these circumstances. So what we did was we're saying, okay, well, there's an issue, right? Because once the DNS settings get frozen, the user isn't able to connect to their home network. They're not able to connect to the corporate network. They're not able to connect to any network. So they would go home, turn on their computer, say, hey, I have a lot of work to do, but they can't connect to the internet. Call the help desk, say, hey, I have a problem. I can't connect to the internet. We know what the issue is. We know that their DNS settings were frozen, but they don't have administrative privileges over their own laptops. So they can't reset their own settings. We can't remote in and assist them. We're not going to give them the administrator password. So what do? Nothing. You're just kind of dead in the water until they get back into the office the next day or whenever they get back in the office, and then you assist them then. So we're getting a lot of calls, a lot of issues, and then a lot of time constraints on actually dealing with this. And the only way that we could think to do it is utilizing the forwarder to fix it for us. So that's what this script comes in. So more PowerShell, more Python. Well, no Python in this one because it's only Windows, but more PowerShell. So we created this script, and what this script is that the forwarder is executing this very frequently. And all it's doing is that it's checking on the system, making sure Global Protect is installed before it does anything. Checks that once Global Protect is installed, does the version check on this particular one, just so we know the version that the issue is occurring on. Then it goes and it validates network connectivity. It checks DNS first on external DNS. If that fails, then it goes and it checks internal IP ranges. So it checks the internal IP. If it can't connect to anything that's an internal IP, then it goes and it resets all the settings back to what it should be and goes and gets that person live again without them ever even noticing. So this is a real true value example of how you can use the forwarder, and actually you can report on this, how much time you're saving, how many issues you're resolving without even having to make a phone call, right? There's so much value to this that it was pertinent to our situation. We couldn't have lived without this. It really helped us out. I mean, realistically, just not having to call anybody and having the issue fixed before anybody even notices was really a great advantage. You're up.
Yeah, let's just a couple slides here to finish up. But I guess before I go into this, are there any questions that anybody wants to ask at the moment to just make sure we have enough time to finish these up and get some questions? We'll also get some questions here at the very, very end too, and we'll be available afterwards and in the Splunk booth too. Okay. All right, so just a few things then. The Splunk app for Palo Alto Networks that we've been talking about throughout the entire presentation is now in version 5.4. It was released last month. It's one of the most intricate and well-developed apps, in my opinion, on Splunk-based, because Palo Alto has a few people sort of devoted to the development of this app, and they've used some various different technologies along the way, like the data models and the custom commands, to make it as good as it can be. Most recent version has better support for traps data coming into it, better support for autofocus, some cross-search functionalities in there. If you're interested in hearing more about it, come stop by the booth. How many of you, I know that we had some people raise their hand in terms of being used in Splunk. How many of you start to get into that Splunk search interface and end up with searches that look something like the one here? You know, they can get very, very complex and intricate and sort of hard to understand for the layman that isn't used to typing searches into Splunk. Is that sort of raise a hand? Like sometimes, there you go. At least one person, a couple of people. Okay. Back at our user conference in October, the question is like, if you had a search like that, wouldn't it be better to type something like this in and actually get a usable answer out of Splunk? So just do some natural language. Let me ask Splunk an actual question like I would ask it in English. So back at our user conference in October, one of our partners called Insight Engines released something called the Cybersecurity Investigator. Specifically, it works against the enterprise security data models, but they've recently expanded it to be able to work against the Palo Alto data models that are in the Palo Alto app. And so I'm just going to spend about 90 seconds to show you what that looks like. And if you get really excited about it, come down to the booth and we'll let you type your own question into it and see what it comes up with. So I'll go over here real quick. Wait for this to sync. OK, cool. So standard Splunk interface, right, with an app on top of it. And you can see this is the Insight Engines app. And this is their demo system. And I'm going to go in here and you can search any of the data models that are within the Palo Alto Networks app. I'm going to stick with some of the pan threat data. But we could certainly do searches against traffic and endpoint, et cetera. But maybe I want to know what threats the Palo Alto detected yesterday. So like, what would I ask Splunk? I could say, what pan threats were seen yesterday? Go. And as you can see, it's working against data models, and it's taking that natural language question that I just asked, and it is converting it on the fly into a series of Splunk searches that are all visible here if you want to reuse them in other places. You can see the data models that it's querying. Here's the data models, the firewall logs data model, and then sub to that is the threat portion of that data model. And then here are all the answers to that question that I asked, returned from the data model. So that's a pretty simple question. I can get a little more advanced with it. I could say, what critical pan threats were seen yesterday? All right, and so now it's automatically going to know, oh, well, he typed critical, so I'm just going to filter this down and just show him criticals. And you can see there's a time range here. I said yesterday, right? I can also say things like, and it'll figure that out, and it'll say, okay, well, 3 days ago, I'll do the automatic calculation, and I'll return that for you. Eventually, it might come back, hopefully. There we go. So you can see it's adjusted the time frame for me. And then I might say something like, we're seen outside of business hours. And sure enough, it's going to say, okay, well, I understand what outside of business hours are, and so I'll go and I'll modify the search to show me what happened, threat data that happened that wasn't between 9 and 5, right? And of course, that's all configurable as well. All right, I'll switch back over to there. We went through that, and there we go. So questions, comments, concerns for either of us? Oops. Oh, F5. Right? Did I break it? Went all the way to the end without a technical problem, and there we go. The slide says, literally, questions, comments, concerns on it. So,
right. Very technical.
Hi. This question is for you, Kevin.
Yeah.
In your SecOps processes, I noticed that you were pulling things like MAC address and machine names, right? And so I'm sure in your environment, people have more than one device, right? So that's something that I'm struggling in my environment is I don't have a Splunk yet, right? I'm doing the user ID with the Palos directly, and the only information that I'm able to get is IP and user name.
Right.
And I'm not able to really do anything with that until I tie it to a machine name and a MAC address. Before, you know, how do you notify the desktop support person of exactly which one of that person's devices is the one with the problem? And I'm wondering how you folks solve that.
Yeah, so the answer to that is Splunk. On a short answer. So you can't, so the Palo Alto firewalls, they utilize, the user ID agent is IP address and user. Those are the two fields that it accepts. In our example, what we did was that we utilized the MAC address on the device to tie two different data sources together, right? So that was the correlating data field that we can utilize to just put those two things together to give us the IP address and give us the user. Now from there, we can parse that out into a table and say, now this is the user IP and MAC address and host name and everything else that we may need, and have that as our historical evidence file since the beginning of time or since implementation time. That way, if we ever get a request, we can be like, oh, well, let's just go back to this date. Oh, okay, yeah, this was their username. This was their IP address. These were the hosts that they were logged into. These were their MAC addresses. Maybe they spoofed the MAC address, and that's what the new MAC address is. So that's really where Splunk comes into play.
So you take like the botnet report from the Palos, the user ID from the Palos, you're feeding back that into Splunk, and the Splunk is doing the output and giving it to the whoever that needs to go clean up that device.
Right.
Thank you.
You're welcome. Right, and it's populating the firewall back, right? So we're getting that information back, but we're also outputting the extra sets of information that we can't push back into the firewall and outputting that somewhere else just so for our purposes in terms of asset management and inventory. Anyone else?
Hello. I have a question related to the threat intelligence feeds. Do you use only the ones that are embedded in ES? And how do you manage false positive?
I'm sorry, what?
How do you manage false positive on the ES threat feeds?
How do we manage false positives?
Yes, and do you use only the ones that are embedded in ES? Or do you use any third-party feeds?
Okay.
Yes, threat intel feeds.
Yeah, so we utilize, we utilize the Palo Alto Network's threat intelligence feeds that are published on PanW site. We also utilize several other open source. We're heavily focused on open source feeds because we haven't had the budget to get a more holistic threat intelligence platform. We do have some industry-specific ones that are paid for or registered, like information security and analysis centers. But we do utilize some of the ones within ES. And we utilize every open source one that we validate and we deem that it does have useful data. Now, in terms of false positives, what we have done is we added a little bit more to the search that it normally does. right? So we've noticed that sometimes we'll get a false positive and it's trying to block or alerting on internal IP ranges, right? Those blocked out private IP spaces. And what we did was that we just added those to exclude those from the data models, or exclude those when we're searching the data models by default, so that we don't ever see those. We don't get those false positives or anything. Beyond just excluding the private IP spaces, we removed certain ranges that we knew for a fact that there were going to be false positives, or maybe we trusted them a little too much. I'm not saying that's best practice, just because technically anything can be compromised, but you do have that flexibility with enterprise security to actually make those changes and customize it to your environment. Does that answer your question? Awesome. Yeah.
Hi, so going back to your integration user ID and from Splunk, so I saw that you're only sending your user ID to Panorama. How do you distribute that to your other firewall? Do you do it at all? Any issue distributing with your other firewall? We had an issue where we have, I think daily we get about 1 terabyte of data because we have about 180 firewalls around the world, just from user ID. So I want to understand how you distribute your user ID back to your firewalls.
Yeah, definitely. So my recommendation is publishing it to Panorama. And I'm not saying that's Palo Alto's recommendation. It's just what's worked for us, just because we populate the ID agent within Panorama, and then Panorama will push it directly to the serial of your primary firewall. Now what you can do is, if you have maybe multiple Panoramas, just because of the amount of firewalls that you have deployed within the world, you can go and run that same search and just say, okay, well, this is the panorama for, let's say, the United States, right? And we could run that search against that panorama device, or maybe that primary device, and then have that same search do the same thing to all the other main regions, or main firewalls for that matter. Does that answer it?
Partially. So do you expect your panorama to automatically push the user ID to the firewall?
Right. So
because so in our case, we log the firewall logs into Panorama and to our Splunk.
Yeah.
But if we just push it to a Panorama, my fear is that the log coming from the firewall might not have the user ID agent.
Right. So let me go into the pan user update. What pan user update does, it doesn't actually populate Panorama. It utilizes Panorama to push it to the firewall. So you choose your primary firewall. Maybe it's in a data center or something like that. And so let me actually go back to one of the searches. So if we look at that bottom search, right, where it says pan user update, panorama, x.x.x, and then serial number, that serial number isn't the Panorama device. That serial number is a firewall. So it's utilizing the Panorama IP address to go and use Panorama to push to a firewall. We just like that centralized point. Now you can also just push it directly to the firewalls, like in this example, right? You can use pan user update instead of Pantag and just push it directly to the device's IP address. So you can do it one of two ways. Actually, I think in Panorama, in the newest version of Panorama or something like that, there's like a weird issue that it might bug out if you try and push through Panorama. So we're actually changing all these searches to push directly to the firewalls rather than utilizing Panorama to push to the firewalls.
Okay, thank you.
You're welcome.
Okay, I think we'll be giving the yank off the stage. We'll go, okay, can we do one more, Lee? Okay.
Thank you.
With that being said, for Pantag, with a single Pantag event, can you push to multiple? Like you said, we run the search multiple times.
Yeah, you can do that. You can. So if the tagging is being distributed across all your firewalls, if you're utilizing one central point of reference and all your firewalls are feeding off of that, because that's the primary template or whatever you're utilizing for Panorama, then you can do that. If you have maybe different tags or different options or just a different deployment of firewalls depending on your location or something like that, you can also tag things differently by utilizing multiple searches, or you can even do it within the same search. You can utilize the same pan user update and just keep specifying it to different firewalls if you like.
Okay, thank you.
You're welcome.
All right, that's all. Thank you very much for attending. Appreciate
Thank
it.
you.
Have a great rest of the conference.